Hi everyone. In this video, I'm going to explain about a project that I have recently completed as part of a database, as part of Code Basics Data Science Bootcamp. The goal of this project was to develop a machine learning model that predicts the insurance cost based on various factors that you can see here, based on the age, number of dependents, their income in the lakhs, genetic risk, or based on all these factors, the machine learning model is going to predict the insurance cost of the user. The user is gonna interact with this web application here that I have deployed in the Streamlit. So here you can see here the user is going to provide age, the number of dependents, their income in lakhs, any genetic risk. And we have three types of insurance plans here. It's bronze, silver, gold. Based on the insurance plan, the insurance amount is predicted. And you can see here the employee status is, I'm keeping it as salary, gender, married, status, BMI index, smoking status, if the patient, if the user have any past disease history, can select here. For example, I'll select this. And based on the details given by the user, the machine learning model is going to predict the insurance cost for that particular user. So here you can see it's 13,85. So by analyzing these features, the model helps in estimating the cost the individuals might have to pay for their health insurance. So in this project, I have followed the project life cycle. I'm going to explain it now. So the first step that I have gone through is data collection and the pre-processing of the data. This data that I have got it from the code basics team, and here I have done some exploratory data analysis and data cleaning. I've checked for some missing values, handled them, and handled the duplicate values, as you can see here. And there are some numeric columns and the categorical columns provided in the dataset. So I'll check for any outliers present in the dataset. One such outliers is present in the age feature. Some ages are greater than 100, so I have removed the ages which are greater than 100. See, you can see here, and after that I used Seaborn and Matplotlib libraries for visualizing the data. Here you can see the age, number of dependents, and income lags. Here we can see the right skewed data for the income. This analysis for numeric features, and you can see here the scatter plot for age, income, and number of dependents, genetic risk. All this is for numerical columns, and for these categorical columns, we can see here we have done feature engineering for such categorical columns. We see here the medical history. This column is having different values like blood pressure, thyroid, heart diseases, and so on. So we have performed feature engineering technique and calculated the risk score for the particular medical history. For example, if the person is having high blood pressure, then the risk score will be 6, and we have normalized it using a minimax scaling method, and we have followed a label encoding for categorical data here. This is a ordinal data here. Let's see here, and we have dropped necessary features that doesn't count for insurance cost. In the next step, we have used VIF, that is variance indication factor, for which causes a multi-collinearity problem, right? So for that, we have calculated VIF for all the features. Here you can see here, for all the features, we have calculated VIF, and in the general practice, the features that's having greater than 10 as a VIF, those features may cause multi-collinearity. So I'll drop those features one by one, and all these things comes under data collection and pre-processing of the data. And the next step is a model training. Well, I have splitted the data into training set and testing set. You can see here the test size is the 0.30, that is 30% of the data is in test set, and the remaining 70 is the training data. For particular problem, I have used a linear regression and XGBoost uh, as regression models. So I have trained the data using linear regression here. The model is trained here, and the scores we can see is 98% as accuracy. And here we have calculated the feature importance, which are the features that are contributing to the final insurance cost prediction. If you see here, the genetic risk is having a more weightage here in case of people who are under age 25, and the normalized risk score. These are the features that are having a high weight when compared to the other features while calculating, while predicting the insurance costs. And the next algorithm that I've used is XGBoost. Here we can see here I have trained the model XGBoost regressor with the here an estimator indicates the number of trees. XGBoost and max depth is the depth of the tree in the XGBoost, and the accuracy you can see here is 98.76, and I've done hyperparameter tuning using randomized search CV method, and the best score that I got is 98.79 here, and based on the linear regression and XGBoost, both are performing great, and they considered the XGBoost algorithm as a final algorithm. And here I calculated the Y prediction, that is residuals, the difference between the predicted value and the actual values here. You can, and I have plotted a histogram here. We can see the normal distribution here. See, the errors are in the range of within minus 10 to 10% errors. And at last, decided to use XGBoost as our regression algorithm, and I've in here we have exported the model into joblib format. Here you can see here. Let me go to my GitHub account and I show you the model, exported model. Yeah, you can see here the exported model, model rest, job lib, this format. After this, building the model, I have deployed the model using Streamlit Cloud. So after deploying the model, I have got this link, and this link you can use to predict the insurance costs. Let me give some values here. Let me give the age as 15, block dependence 2, income, genetic ways, the plan. Let's choose the bronze plan. Salary, male, married, normal. Let's choose obesity. Let's choose regular smoker, not the high. Okay, let's predict. Here we go. We got the insurance cost us 17,469 piece for these parameters. Let's give the age to 25 and let's predict it. See, based on the age, based on these parameters, the health insurance cost is very person to person. So the key highlights are the, the model predicts insurance cost based on these parameters, and the tech stack that I have used is Python, Pandas, Scikit-learn, and Streamlit for deploying the model. And the key insights that I have got is the generic risks and BMI features played a key role in predicting the insurance cost for people who are under age 25, and the age and regular smoking played a key role for calculating for predicting the insurance cost for older people. So in this post, I'm gonna attach the GitHub link and the web application link, so you can go and try different values, try to give different values for these parameters, and you can predict the insurance costs based on these values. Yeah, it's a good learning from core basics. Yeah, thank you.